Recording be available afterwards. Yes, definitely. Adam, where are we going to host the recordings?
Likely on our YouTube channel, which is YouTube/@Tangram Vision.
There you go. Well, I think we'll also be sending out an email after the webinar with a lot of this information.
Great. Why don't we go ahead and get started? Hopefully you can all see my screen, and soon after you will see Brandon's screen. So to start, I'm Adam Rodnitsky. I'm one of the co-founders, and I'm the COO here at Tangram Vision. Brandon Miner, my co-founder, and our CEO is joining today, and he'll be taking you through most of the presentation. Before he starts, I thought I'd just give everybody a quick introduction to Tangram Vision and what we do, as well as a bit of detail about MetriCal before we jump into that. So Tangram Vision, we are a team of perception experts, and we build perception infrastructure. What we've been most known for is multimodal sensor calibration. We have two tools for that. We have MetriCal, which is our sophisticated offline bundle adjustment tool, and that's what Brandon is going to be taking you through today. But we also have AutoCal, which is online calibration for on-the-fly calibration, recalibration, and health checks. That is currently in alpha. If you have interest in testing that out, please reach out afterwards. We'll get you access to the alpha. Recently, we launched Hi-Fi, which is our new high-resolution AI-enabled depth sensor. We'll talk a little bit more about that in a second. And then we do a limited amount of perception consulting for some of our customers where they have particularly tricky problems that we can help them solve. So just a quick note about Hi-Fi. It's our new 3D sensor. It is pretty incredible in terms of specs. It has triple the depth resolution of any competing depth sensor. It has 4 times the AI compute of any currently available depth sensor. And it has lots of reliability enhancements to make it really great in deployment environments. The reason we made Hi-Fi was because we have a lot of customers that use other depth sensors where they were disappointed with depth map quality or reliability or limited AI. And this is really sort of their product more than ours. We just took all their feedback and created this. We are going to be shipping Hi-Fis in about 6 to 8 weeks for our first customers. If you'd like to get one, go to tangramvision.com/ I think it's pre-order, and you can pre-order one and still get $100 off the MSRP. We have a lot of other resources. We're very proud to support the perception community with lots of education and knowledge. Many of you probably are familiar with our blog. If you aren't, there's 70+ in-depth tutorials and resources for learning about things like calibration, distortion models, etc. We contribute regularly to open source projects, probably most notably RealSense Rust, which lets you easily integrate a RealSense device into a Rust environment. We've built a pretty cool depth sensor visualizer that lets you compare over 30 sensors. Oddly, Hi-Fi is not there yet. It should be. It will be soon. We're going to be creating a LiDAR version of this soon. And then we have our calibration desk reference, which is 80+ pages about calibration. You can get a free PDF of it online, or if you'd like, you can purchase a hard copy on Amazon. All of this resources will be in links that we share with you after this webinar. So with that, I'm going to hand it over to Brandon, who's going to start by telling you a little bit about MetriCal, and then he'll go into the demo.
Yeah, so fun times. Live demo today. Well, sort of live demo, but I'm very excited for today because this is our very first product webinar. We have had webinars before around topics on depth perception, perception tools, but we've never actually shown off what we've done to do that. And so MetriCal is a tool we've been developing for the last 3 years to kind of be our solution to multimodal calibration. And we'll get into kind of exactly what it does here. But first, for anybody who's unfamiliar, you probably are since you're at this webinar, but calibration is kind of the way you understand how your sensor operates with the world. So this can be understanding, it's what we call intrinsics, so how you can model what it's seeing or what it's doing relative to itself and the space. Or you can model its extrinsics, so how it relates to another sensor on your system, right? And both of these are important for things like sensor fusion, mapping, navigation. At Tangram Vision, we really see calibration as the key and the core of perception. If you get calibration right, everything else is much easier, right? And so we've made a huge concerted effort to make the best calibration system possible. And here it is with MetriCal. MetriCal is multimodal. So any camera you have, we can probably work with. We have 7 different camera models spanning from what you see in OpenCV to EUCM, double sphere, a few of our own camera models even that you can play around with and see what's best for your camera. But beyond that, we also do the intrinsics for an IMU, give you scale, shear, rotation, and the sensitivity to gravity. All of these things, you may not need them all, but depending on your application, they could be vital to getting these things right. And so beyond that, we do extrinsics between camera IMU, camera LiDAR IMU, LiDAR. Sensor chassis is another thing we've exposed recently. And then in development, we're putting in radar and 2D LiDAR. So very soon, MetriCal will be able to do basically anything you want with a perception system. And the best part is that it does it all at the same time, right? And so MetriCal is not a piecemeal operation. We calibrate every modality in the same data set at the same time using the data that you probably are already recording off of your system, right? And so what this allows us to do that MetriCal offers above any other calibration system is give you a complete picture of what's happening at that state of time, kind of a perfect snapshot of your system at a moment in time, right? Complete accuracy and precision metrics to know exactly how good that data is for calibration, what the calibration was, and how you can apply it later on. Right. And so when we advertise MetriCal to our customers, we really say, it's fast, easy, and correct. Those are the 3 points we want to hammer home. It's fast because you can kind of just slap up targets and it works. We'll get into that in the demo. It's easy because it's designed for untrained operators. You don't have to be a computer vision scientist to get through it. And it's correct. It's, you have the accuracy and precision metrics for every parameter in your system to provably, verifiably know that this calibration will work for you. And so that is what I'm excited to share today in the MetriCal demo. So I guess I can share my screen now, Adam.
Yeah, so let me stop sharing it. Just a quick note, if you want to follow along with Brandon's demo, it's going to start at docs.tangramvision.com. So feel free to surf over there. Don't have to. But that might give you some additional insight. So with that, Brandon, I'm going to toss screen sharing over to you.
Cool. So let's do that. We are very proud of our documentation. We see it as one of our differentiators in the calibration space, in the space in general, right? So I'm going to start at the top. Basically, here's the MetriCal documentation, docs.Tangram Vision. The rest of the tutorial will assume that you've kind of gone through this and have a license. But for the sake of example, I'm kind of showing you what we're going to be diving into. MetriCal is a Docker image. It's not a program you have to download or work into your existing workflow through hacking or anything like that. It's a very simple CLI tool. Again, emphasis on ease and ease of use. You basically just download it and it's ready to go. Once you have the license, you provide it to the CLI. And we have different CLIs to use. So if you'd like to use a stable release that has documentation, 8.0, 7.0, that's here, CLI.latest. But then you can also follow along with us as we develop the tool with dev releases. And a lot of our customers like to do this as they give us suggestions for improvements or new modalities or something like that. We may not have time to put it in a release for a week or a month, but they'll be able to test it as we go and give us this valuable feedback. And so you'll see I'm on version next of our documentation. That is referring to dev latest. That's not to say that you can't follow through this tutorial with 8.0. For instance, you absolutely can. But next is where we put all the latest documentation, again, from these from customer feedback. So you'll find a lot of good stuff here. Throughout, I'm also going to be using this command called MetriCal. That's a shortened alias for this big old thing, but don't let it scare you. This is mostly Docker infrastructure, not MetriCal infrastructure. So again, you should just be able to copy this pretty much wholesale and get ready to go. So with that, we will move on to our tutorial. And today it's going to be something probably everybody sees as a little bit boring, a little bit rote, but recalibrating RealSense sensors. So I chose this as the first tutorial of many coming this year, because even though there are more exotic and fun ways to use MetriCal in a system, RealSense is like the Starbucks of the sensor world, right? It's whether you love it or hate it, you've probably had one in your system at some time. And a lot of our customers, whether or not they want to move off of it or move towards it, do use MetriCal to calibrate RealSense from 1 to 7 to whatever number they have, right? And again, one of the joys of MetriCal is that you can do this all at the same time. So no matter how many RealSense sensors you have, you can just process them all and get the right results. So we're going to be going through this today using Tangram Vision code to both record the RealSense data set, process the RealSense data set, and then flash it on. All of these things are available through our open source and MetriCal tools, and we'll go through how to approach that here. So at the top, we're recording data. A lot of the MetriCal will yell at you if you're recording the wrong data for some systems. RealSense is one of them. RealSense is a very specific type of parameter space it expects for calibration. If you're streaming anything else, it will rectify it for you, which means that by the time you get to a calibration, you're not actually calibrating anything. You're calibrating the calibrated parameters of the RealSense. And this applies for a bunch of all-in-one sensors on the market. So specifically for RealSense, when we go to calibrate it, we're looking for these settings. For IR, we want to stream Y16, which is a 16-bit IR channel at 1920 1080. For color stream, you want to do YUYV, also use YUY2, 1920 by 1080. You'll see that in the documentation, I actually call out RealSense Rust. We can head over there right now. And in the RealSense Rust crate that is developed by Tangram Vision, you'll see in the examples, there is this record bag.rs. Basically, what this allows you to do is record a ROS bag with the exact parameters that we're describing today. You don't have to do anything else. You just plug in your RealSense, do record bag, and it records for 30 seconds.
Brandon,
so that's what I did. Oh, yeah.
You're staying on the dock screen. If you meant to go to another window, you may need to move it.
Lol. Okay. Well, all that being said, there's a record bag result in the Rust docs that you can use to do exactly what we did today. And on that, I'll show you the fiducials we use because it's kind of cool. So I'll be showing you my data set that I used with these 3 big boards. Now, you don't need to use 3 boards. This is gratuitous. And it will allow me to kind of calibrate whatever I want using my big bundle of sensors here. But you'll see right off the bat, we're using 3 boards. This is unique to MetriCal. Kind of hard to do with any other open source tool. And we'll see how easy it is to use 3 boards in just a bit through the demo. So we've recorded our calibration data set, which you'll see is pretty rocky when we get there. Because motion blur is a thing. Motion blur is always a thing with cameras. And one of the other things we'll see with MetriCal is that it will actually filter out motion for you as you go. Again, very easy to use. You don't have to consciously think about these things when you're taking data. And then we identify the sensors that we want to flash. And this will become important when we actually put the calibration onto the sensor, which we'll do today. So running MetriCal, this is kind of the fun part. This is the part I wanted to show you. This is assuming, we have our data set. We have 30 seconds of ROSBAG recorded with our sensor. And this could be, again, any number of sensors going at the same time. But here we go, share. So, Adam, can you see this?
Yep, I can see it.
Cool. Are you seeing the full window all the way to RS Cal Flasher all the way over here?
Yep.
Cool. So when I said MetriCal is super easy to use, I meant it. This is literally all we need to write for the complete process that I've just described. And most of it is just boilerplate, just telling us where to find things, right? So we told our data set is going to be in my Tangram datasets Tangram. The demo RS all streams is where I'm storing it. I've recorded a ROSBAG, which then I converted to an MCAP, though this is not necessary. And really the only other configuration job I needed to do was tell it what objects I was seeing in the scene. So that was when we were talking about those boards. And I'll bring that up now. So what this does is, if you're familiar with other tools, this won't seem so foreign. Basically, all we're saying is that we have a marker board. The checker length is, 0.12 meters. The marker length is 0.09 meters. We're using a Ruco 5.5 or 5x5, and it starts at ID 100. And we have 3 of these, right? So we have marker board, marker board, marker board. This is all the setup needed for MetriCal. You basically just describe your fiducials, and then you're good to go. MetriCal will do the rest. So we've described our 3 fiducials here. In total, it's 49 lines of JSON, and most of that can be basically copied right out of the MetriCal utilities repo, which we'll get to later. And so we've described our here we go. I'm going to make this a little wider because we have some cool tables.
Hey, Brandon.
Yeah.
Sorry, you just froze for probably the last 20 seconds. So why don't you rewind a little bit?
Gotcha.
And go back.
Classic. Okay. So I probably left off with object space.
Yes, probably.
Yeah. So we had our object space, our 3 targets described. We have our data set, which is my MCAP that I recorded off of my RealSense. And then we're going to let MetriCal do the rest. So init will take a snapshot of my system with the data in hand. So basically, we're going to use the data that I recorded to say, this is roughly what my system looks like and what I can expect. And then we're going to use that to pipe into the calibrate mode, which will say, what is my actual calibration given this data? And so we'll go into kind of what these do when we run them. But really, this is our entire process. To get to calibration, it's 2 lines. So let's see, terminal, new terminal. Here we go. And here we go. So we're going to run rscal.sh, which was that script we just had. Let's see, there we go. sh, here we go. And here, I'll actually run this piecemeal so that we can see what's happening. So we're going to run MetriCal on it first. And now we'll see that what we're doing is going through what MetriCal has done. in this very quick instance is run through all of our data and collect the model that we're going to be using, which for all of our images, all of our image topics is going to be OpenCV RAD10. We're using the OpenCV image model. This could be different things like EUCM, double sphere, or you could do even things like Brown-Conrady, or I think there are 4 others, but whatever you want to do, we can have it here. And it's as easy as just kind of assigning a topic to a glob of topics. So we've skipped over some topics that we didn't need. We've assigned some topics, for instance, sensor 1, infrared 2, data camera, OpenCV RAD10. And at the end of that, we've created what is called, in our parlance, a plex, which is that snapshot of the system at a moment in time. So whenever we're initializing or creating calibrations, it's always going to be with an output of a plex, because that is our virtual calibration at that moment. So with our initialized plex, which is kind of saying, this is roughly what I should expect, you can see we have dummy values for our calibration. So our name infrared 2 data topic has, pretty rote F, CX, CY. Here's the height and width of our image. And it did that for every topic. And then we have spatial constraints, which tell us the actual extrinsics between topics. And then we'll have temporal constraints, which tell us the time synchronization between topics. And so traditionally, in a traditional calibration, you would have to describe these things to the system itself. MetriCal is smart enough to know that by itself. So there's no setup. It's just running in it and letting it go. So now that we have an initialized plex, we can calibrate using that initialized plex and say, given kind of a rough idea of the system, here's what I want to see, and here's the output. So let's do that. This is where the fun begins. So we're going through our system. We have 3 topics we're looking for, the images, and we're reading and syncing them now based on the input plex, the timing and spatial constraints. And a lot just happened, and our results are looking good, but let's go back up and see exactly what occurred here. So first thing that MetriCal does really well is filter out data that does not need to be there. If you've ever run a calibration with too much data or bad data, you'll know that that's actually just going to throw off the entire thing, right? You're basically fitting a model, and if that data is bad, your model will be bad. MetriCal preemptively fixes this for you by running a few filters. So for images, we have a motion filter specifically for things like motion blur, rolling shutter, et cetera, et cetera. We filter those out for you. So 436 frames, we only found 21 of those for this topic to be useful. And only 17 of those had features. So ultimately, we've gotten rid of 410 frames that would have, detrimentally affected our calibration. And we've done this for all 3 cameras. So now we have the objectively best data to go with going forward. And with that best data, we can now see how well we've detected. So here's a binned feature coverage of these images. You can see for infrared 1, which is the left camera, we have most of our features in the middle. Usually I would want to see more features on the outside, but for the sake of demonstration, I think this is fine. Infrared 2, it's the same. You'll see most of the features are centered inside. We would need more outside. When you're running this yourself, MetriCal provides these metrics at the very end so that you can actually program a go, no go for your production line or for your team based on these. So if you're looking for metrics on the outside and anything else is a failure, we can just program that in. Same for color. Color for RealSense is pretty tough because it's a rolling shutter camera. And so you can see a lot more got filtered out than with the infrared. But still, we were able to get some good features that we'll use later on. And here's another interesting result. Here's our synchronization graph. So as we go, you'll actually be able to see how these observations synced together. This is important if you have poor time constraints or poor time stamps in your data. You can actually just see it right here in the graph, even before you've done a calibration. Everything will just look lopsided, or things will be shifted off in a way that you don't expect. So again, one of those pre-checks on calibration to make sure that what you're doing makes sense. At the end of that, there's actually a mode in MetriCal to say interactive mode, which would say, after all these pre-processing metrics, is this a go or a no-go? Operators have the choice to say yes or no based on what they've seen. For now, we've just gone through and automatically calibrated. And you can see, the calibration took 2 seconds. We've stress tested MetriCal with, data sets with a LiDAR IMU and like 20 cameras. And even with that kind of load from beginning to end, we're finding 6 minutes and 30 seconds, right? So whatever system you've used, MetriCal is probably faster. And if it's not faster, please let me know, because I would love to figure out how we could fix that. But you see, we did calibration in 2 seconds, and now we have a complete set of results based on that. First off, we're going to go through these, and they're pretty great. Stereo pair rectification error. A lot of our customers use arbitrary cameras as stereo pairs, or they at least like to know how well they align based on the model. So MetriCal will actually automatically detect stereo pairs, regardless of whether you've deemed them stereo or not, and run a rectification process. So you can see here, we rectify between the left and right eye. Dominant is left, secondary is right, which is what you would exactly see in a RealSense. And you're seeing the RMSE for this per pixel is very low. We're getting 0.07, root mean squared error between these lines, which is perfect. That's exactly what you want for depth. Of course, we would want to see more features for something in production, but for now, what we're seeing is great. Bin reprojection errors, same thing. So this is our features above, but just reported as the actual error from our calibration. And you can see, again, these are looking pristine, 0.03 pixels, 7.2 to the negative, 3 pixels off. So there's no issue with this calibration other than more data, right? And then at the very end, here's the full camera metrics. This is the actual camera intrinsics that we derived. Again, we have these 7 different models. So now we're modeling OpenCV's traditional distortion, but this could be anything. And best part, we're able to see both the value and also the variance from the calibration. And you'll see here that the values look reasonable, but the variance is kind of high for F, CX, and CY, 3 to 2 pixels. This is probably because of the data we've captured. It's not enough to actually lower that variance to a level that we would like to see. For instance, K2 is 0.019. We would want to see that over in F, CX, and CY as well. So again, just one of those gut checks. If this is too high, you can actually cut the calibration off and make sure that things are reasonable. But for now, again, for the sake of example, we're going to run with this and see how it goes. Calibrated extrinsics come next. One of the unique things about MetriCal is that you don't assign extrinsics between X and Y. Whatever it can solve for, it will. So here, even though we have 2 extrinsics, there are actually 3 in the file. And for multi-camera, multimodality systems, you'll find that this number can blow up to 5, 20, 40 extrinsic pairs between sensors. And what MetriCal does for you, conveniently, is it finds the minimum spanning tree of the best extrinsics in this graph. And what the best means is that it has the minimum covariance between components. And so what you can actually do is find the span between 2 components that is the most certain in your system. So here, the most certain calibrations are between the left and right pair and the right and color pair, which makes sense because you go left, right, color. Those are most close together. But as you get into more nebulous graphs, something like this can become very difficult to do in another system, because you might have, angled cameras that don't look anywhere near each other. But with MetriCal, you can actually make that leap and find the most secure extrinsics pair for you given your data. And there are a bunch of tools native to MetriCal to do this. So we have MetriCal shape command in the documentation that will output a minimum spanning tree of these extrinsics. It'll output a hub and spoke model. So if you have everything related to a chassis or a certain component, it will do that graph search for you and put it out. You can do, extrinsics to extrinsics, any number of these things. You can output to URDF for ROS. So we try to make that as easy as possible, because we understand that, it's a big complicated graph, but what it has in there is the best result possible, and we want you to get that. And so at the end here, I just have some summary statistics. Basically, this is a great calibration given the data we've seen. We understand that the data we've seen is lacking, obviously, but MetriCal makes that obvious for you in case you wanted to do something else. And I will actually switch my screen to another window to show you something even cooler. Adam, can you see this?
Yep, I can see it.
Cool. So we've gone through all the nitty-gritty, the data, the numbers behind the calibration. But what we also do is show you the actual calibration as applied to your data. So when you run with the -v command in MetriCal calibrate, you can actually just visualize what we're doing. So here, thanks to our friends at Rerun, we have put together a visualizer for our data. MetriCal is natively written in Rust, so Rerun has a great Rust toolchain to do just this. But I think it's worth mentioning, we use two visualizers usually, Foxglove and Rust, or Foxglove and Rerun. Foxglove is for kind of preemptively looking at data based on ROS bags or MCAPs. Rerun is when we apply the calibration. So both have their uses, but for now, Rerun is what we're looking at here. And you can see this is the data we gathered. Data with detections is sent to Rerun so that you can actually see what was detected. If I expand this, you can see our little dots here. These are the corners we detected. These are the features that we've seen. And you can see this for color as well. Color here is YUYV, and in MetriCal that gets converted to grayscale. But there's no loss for for these type of fiducials. And so you can see as we go kind of these detections. But then we can move to the corrected dataset timeline and see how our applied calibration actually looks. So this is the data. I captured it with my 3 boards. And we'll let it play here. You can see if we didn't have that motion filter in MetriCal, this would be pretty hairy. The color camera has a lot of blur, again, because it's rolling shutter. Whereas the IR pair looks pretty good. But since MetriCal kind of does this natively, we didn't have to worry about it, right? It was still the 2 lines of code. And so here it is applied. That calibration looks really good. Here's the end result of our Plex. This is looking fine. So, and again, this comes natively. We're updating Rerun from right now. We're on version 0.8. We're going to go to 0.13 or something like that. But this functionality comes right out of the box. Just run it right beside Docker, and it will set a network connection and basically just send it to your host. What's cool about that, though, is that you can actually run Rerun on an entirely different system on your network and still get this visualization, which we've done kind of playing around at retreats and stuff. So one system will have MetriCal running, and then somebody else's system will actually have the visualization up and going, which is really cool. So distribution built in. So let's go back to our RS demo. And so we've gathered a calibration. We have the results, and we can actually just see what those are like here. Here we go. So here's our complete covariance matrix for our camera. This is where we were pulling those variance values that we saw in the table. If you wanted to go even deeper and find the covariances between, my focal length and CX, or CX and something else, you can actually do that here. And here are refined intrinsics based on our data. So you can see F is much bigger, CX and CY are much different. And again, you have a complete system for getting these things done. One of the also interesting things that you can do with MetriCal that I'm not describing or not going to demonstrate today, but we'll demonstrate in a future tutorial, is that we assign every component a UUID. And this is only worth noting because the component is assigned the UUID, not the data stream. So if you have a system that you want to track its calibration over time, what you can do is actually in your MetriCal init command, you can actually just give it an initialized plex. You can give it, I think it's like initial plex, old plex. And what this will do is bring in all of the data from the old plex here and seed it for the new plex, preserving those UUIDs. And so over time, you can gather how your calibration has changed by comparing the UUID over different plex files. And so this is something we do with customers regularly who want to rigorously test calibrations on their system, or see how calibrations have drifted over time, given manipulations or changes to environment, things like that, right? That functionality is going to become easier as time goes on, but for now, we provide scripts to do this through Jupyter, etc. So we've now initialized and calibrated, and we have all the information needed to flash. And now we use RealSense Rust Flasher. And this is a good time to bring up the MetriCal utilities repo. So every time someone comes to us with a new problem in MetriCal, we'll address it, put it in the tool if we can, and then add functionality for other people to try it out, right? And so I will share my screen again for this utility. So this is the MetriCal sensor calibration utilities repo. It becomes more robust day to day. You can see we have utilities for different examples. Everything I'm doing here is in the MetriCal resources. Hardware support for RealSense holds our RealSense calibration flasher. Take the results from MetriCal directly and flash them on, which is something we're about to do today. Different object-based templates, JSON schema for all our results, so you don't have to painfully look through exactly what's doing where. Examples on spatial constraint traversal, kind of that minimum spanning tree that we were doing earlier. So all these tools are here, and as you find more ways to work with the tool, we'll just continue to expand it. But for now, we're going to use the RealSense flasher here, which takes a plex and takes a description of your sensor's serial number and flashes the calibration directly on. And so if we run this, which I did off screen, you'll see that it takes the current calibration, finds the plex configuration that we just showed, and uploads it directly to RealSense. And it does this for any number of RealSense. So you can have 7 different RealSense connected, and it will find this and parse the plex, right? And so if we run RealSense Sense Viewer, it's a very, here we go, share screen, window, Intel RealSense Viewer. Here we go with that flash calibration. So there you go. Sharp lines are looking sharp. It's looking pretty good. I did some depth testing earlier against the flashed calibration on this device, and they were nearly identical. I was getting not even a centimeter of error between the two, which tells me that this is working pretty well, even given our bad data set, right? And so you can imagine being a little bit more disciplined with this if you had installed a RealSense and it had actually twisted. MetriCal will allow you to get that calibration going in no time at all for any number of these sensors. And that was it, really. So all we've done is run 3 lines of code. And in that time, MetriCal figured out what we were doing, derived the correct calibration, given pretty bad data objectively, and flashed it on. And we were able to verify both through numbers and through visuals that this calibration is looking good. All of this is on our docs. Again, we're really happy to provide those. And as I go through more of these,
Looks like Brandon has frozen one last time.
oh,
Brandon, you froze one last time.
okay. I was saying here, some health bars for my dog. There we go. As we do more of these, you'll see I have a LiDAR here. I have my ultra wide field of view lens. So we'll be doing more demonstrations of how this can really beef up your pipeline. But for now, I thought RealSense would be interesting to do because, like I said, it's the Starbucks of sensors. Everybody has it. And hopefully you can, if you have one, you can download MetriCal today and just get going. Don't have to worry about this ever again.
Yeah, so there were some questions coming in during your presentation, and I answered them. There's one that I didn't, which you know better than I do, so take a look at that. And maybe we can also, I'm not sure if attendees can see other people's questions and answers, but if not, we can probably just verbally go through some of these. And if you have other questions, please put them in Q&A. We'll answer them.
Yeah, absolutely. So where should we start for these questions?
Well, maybe start with the one that's not answered yet, which is, does MetriCal support a customized camera model?
Oh, so we would work with you to integrate that in. So we have a couple of customers who use some more unorthodox camera models, and we've worked to integrate them in. That's kind of how we have EUCM and double sphere. It's very easy for us. Mathematics is not difficult. Just tell us what camera model you have or want to work with, and we can put it in. That's it. Yeah.
Another question was, do I need to provide an initial guess for sensor extrinsics, like a URDF, for example?
No. MetriCal init does that. We have never seen a case where a customer has gotten better results with a seeded extrinsic. We've done it before to verify results, but we've never done it to make results better. And so MetriCal init and MetriCal calibrate have done the job, and I think they'll only get better.
Along similar lines, can MetriCal calibrate extrinsics among multiple cameras that have no overlapping FOVs?
Yes, they can. That's something I didn't do very well today because RealSense is RealSense. But if you have a target space that allows for that kind of overlap, all MetriCal needs is one camera looking at 2 targets or 2 cameras looking at 1 target, and it can make that math work, right? And so, for example, with my setup, if I had 2 cameras that were completely orthogonal to one another, what I would probably do, and what we've had customers do in the past, is basically set up their system like this, right? Kind of orthogonal. And so as their system or robot or module rotates, we'll be able to see exactly what that object space is doing and calibrate for it. So there's nothing else you need to do there. It's the same kind of procedure I described today.
I'm going to bundle in 3 questions that are about modality support. Do we support 2D LiDAR, 2D laser scanner, really 2D LiDAR, GPS, and kinematic models?
So we are on the way for 2 of those 3. We have 2D LiDAR support we've tested, but we don't have it integrated all the way up into the main platform. That's something we're working on. GPS, we have a very sophisticated IMU model. And from there, we're hoping to kind of bootstrap our GPS system. This is something we have customers today wanting. But for kinematics, there are a couple ways I could take that. That could be like a robot arm kinematics, or it could be wheel encoders for a robotic vehicle or something like that. I would say we're closer to wheel encoders than we are a robot arm or something like with multiple degrees of freedom mini joints. And this is purely because MetriCal's mostly been in the perception mode. You can see, cameras, LiDARs. IMU's kind of our first foray into motion, and I think that'll become more important as we go. But right now, it's not a focus. We're trying to get those perception modalities correct.
Cool. Does MetriCal have or plan to have a live data capture tool that gives users real-time feedback?
Yes,
on the calibration data set?
It does plan. I swear. So one of the reasons we started with Rerun, I know. It's we have, so here's the deal. I'll be very blatant with you. We have AutoCal that currently takes live feedback and does an adjustment without fiducials for cameras. We have MetriCal, which takes recorded data and does everything for everything. We have a visualization tool set that works with both, but in different ways. So our job in the next month to make this happen is basically merge these 2 modalities, input and output, and then have some bridge between, ROS streaming or MCAPs to allow live coverage. That's it. We have this written out. We have it as a to-do. It is on our, but there's just a little bit more work to make that happen. So I would say look for that feature in the next 2 to 3 months. It's something everybody wants. I'm very eager to get it done. It's just not there yet.
Cool. So with that said, if there are any other questions, actually, sorry, there's 2 more coming in. We'll do these last 2, and then we'll probably wrap up. The first one, can you run MetriCal on NVIDIA Jetson?
If you can run the Docker instance, I don't see a reason why not. MetriCal is a CPU process. It doesn't use any GPU. So if you're asking if you can utilize Jetson in kind of a heavier way to make MetriCal go, not quite yet. But we do have a lot of customers who use NVIDIA platforms. This is probably something we'll explore more in 2024.
I would also say that AutoCal is probably more relevant in this case.
Sure.
Because AutoCal is an agent running live on device to do recalibration, which leads into the last question, which is about online calibration / AutoCal. Does it support ROS2?
All of our data input uses the same library, and so it will support ROS, ROS2, MCAPs, and whatever you have right out of the box. Just kind of exactly what MetriCal is doing.
Great. So if you have other questions that we didn't get to in this hour, feel free to email us at the address on the screen right now, metrical@tangramvision.com. We're always happy to chat perception, calibration, sensors, etc. And so, yeah, just to wrap up, MetriCal, it's super fast, calibrates very complex systems in seconds to minutes. We have some customers that have literally over 20 cameras and multiple LiDARs, and we calibrate those systems in about 5 minutes. It's easy, 2 lines of code, completes it, and it's correct. You know that the data is actually correct because we tell you when it isn't, and usually it is good. So, Brandon, I'll let you wrap up with your contact info. Yeah, so, you can email me at brandon@tangramvision.com. I would love, so this is our first product webinar, of course. If you have something you would like me to cover or you'd like the team to cover in these, please let us know. We have a lot more lined up for 2024, but if there's something you want to see,
give us a shout out. Of course, request a trial, MetriCal at tangramvision.com, or just email me or Adam, of course. And then check out our stuff, tangramvision.com. The blog is there. Our documentation is there. We're on most socials at Tangram Vision. That includes LinkedIn and X, I suppose. And thanks for coming, I suppose. I hope that wasn't too much. I'll work on it and we'll get better. But
Thank
I
you,
appreciate
everybody. We'll follow up with an email that has links to all those resources we mentioned earlier. The recording of this webinar is going to go onto our YouTube channel, and it might be sent to you. This is the first time we're using this platform, so I'm not quite sure, but we'll see. And yeah, thank you all for joining us today. We really appreciate you spending time with us.
Cool. Have a great day, all.
Thanks, everybody.